Good afternoon, everyone. Welcome to Screencast number 2, the screencast in which I, your teacher, Mr. Ripes, present to you a real-world problem. And then, using what we know and we learned in class, we solve it using that information. And then after that, I present to you your own real-world problem in which you have to solve using similar techniques. All right, let's begin. Here is the one that I want to do and show for you. It has to do with a first aid kit. You are making first aid kits to go camping. You have 48 bandages, 15 squares of gauze, 6 tubes of antibiotic ointment, and 6 ice packs. That is definitely being prepared. What is the greatest number of identical first aid kits that you can make? The key word there being identical. In other words, you want the same number of items in each of the kits. So what is the greatest number of identical first aid kits that you can make? And then the second question is, how many of each item will be in each first aid kit? Okay, well, let's solve both those problems, but we'll solve the first one. The first question being, what is the greatest number of identical first aid kits that you can make? To solve that, just like we did in class, we need to find the greatest common factor, also known as the GCF, of the numbers 48, 15, 6, and 6, which, as you can see below, I have organized right here. So let's do it for 48 first, which is definitely going to be the largest prime factorization tree. 48, you can take 48 a few different ways. I decided to go the 6 and 13 route, which is fine. 3 we know is prime, so we circle that. But we know 16 is not, so therefore 16 is, 4 times 4, 8 times 2, however you want to look at it. You're always going to get the same numbers in the end. Both these 4s are, of course, not prime. Each of them are 2 and 2. And remember, circle your prime factors because that's where it ends. So that's 48. Now 15, that's an easy one. 3 times 5, both of which are prime. And look at this, we both have 2 6s. All right, so that's nice. Each of those are 2 and 3, or 3 times 2 as it were. And both 2 and 3 are prime numbers. This we know. So that didn't take too long to figure out the prime factorization of all 4 numbers. Now, remember what we did in class. We stack each list up on top of each other. Be sure to write your prime factors in order from least to greatest. This is called descending order. So 48 is 2, 2, 2, 2, 3. All of them multiplied together. The gauze is 3 times 5. And the ointment and the ice packs are both 2 times 3. All right, so we have all the information we need to figure out the GCF. And to figure out the GCF, we have to look for, that's right, what is common amongst all, in this case, 4 lists. So, is 2 common amongst all 4 lists? No. But is 3 common amongst all 4 lists? I believe, ladies and gentlemen, that it is. There's a nice lopsided ring of 3s. Is 5 common amongst all 4 lists? No, it is not, and that exhausts all of our numbers. So the GCF is actually very easy to calculate. It's only the one number that is common amongst all 4 lists. Now remember, for every group that you create of common factors, you only extract the number itself. So yes, we have 4 3s, but we only use one of them. And the GCF, thus, is 3. Hereby answering the question above, which read, what is the greatest number of identical first aid kits that you can make? The answer to that question is 3. You can make 3 identical first aid kits. All right, so we solved that first part. How many of each item will be in each first aid kit? How many of each item will each first aid kit contain is what the question is saying. I reworded it a bit, but it's the same thing. In other words, if you want to make 3 identical, and we know it's 3 identical first aid kits, and we have at our disposal 48 bandages, 15 squares of gauze, 6 tubes of ointment, and 6 ice packs, well, knowing that we need to make 3 identical first aid kits, the mathematics really kind of speaks for itself. We don't have to find the GCF. We've already done that. Think about it. If we have 48 bandages and we want to make 3 identical and we want to divvy up the bandages so that there's an equal number in each, well, that's not too bad of math. We take 48 and divide it by 3. And we know 48 divided by 3, that's easy math. That is 16. So we're going to have 16 bandages in all 3 of the identical first aid kits. All right, let's do similar math for gauze. 15 divided by 3, of course, is 5. 6 and 6 for ointment and 6 packs, or for ice packs. 6 divided by 3, of course, is 2. And of course, we'll do the same for the ice packs. which means to answer the final question, how many of each item will each first aid kit contain? Well, let's see here. We said there are going to be 16 bandages, there's going to be 15 squares of gauze, 2 tubes of ointment, and 6 ice packs. There we have it, folks. We answered the question. There will be 3 identical first aid kits, each containing 16 bandages, 15 squares of gauze, 2 tubes of ointment, and 6 ice packs. Congratulations. Nice job. That is the problem I wanted to present to you, and now for yours. Here it is. It has to do with space travel. In the future, scientists may want to make a unit of time that is convenient for people living on both Earth and Mars, which is assuming people are going to be living on Mars in the future. That would be pretty cool. The new unit of time, called the space hour, should divide evenly into the number of minutes in each planet's day. That is crucial information. Under the current Earth definition of minutes, that's a very interesting way to think about it. Earth has 1,440 minutes per day, which is true. That's how many it has. And Mars has approximately 1,480 minutes a day. Wow, so they have a bit more than us. Not too much more, but a bit more. That's interesting. All right, part A. What is the greatest number of minutes that could be in a space hour? That is what you are required to solve and show your work for, and explain how you got your work. How are you going to do that? Well, here's a hint. Find the GCF of 1,440 and 1,480. That will give you your answer, the greatest number of minutes that could be in a space hour, because we know to do that based on this sentence here. The new unit of time, called the space hour, should divide evenly into the number of minutes in each planet's day. Thus, you are looking for a common factor. In this case, you are looking for the greatest of the common factors, known as the greatest common factor, hence the name. So find the GCF of those two numbers, and you'll have done part A. But remember, explain yourself, show your work, all right? Now look below, there's also B and C. B and C, I want you to make an attempt on. They're a bit more challenging. However, I will be looking at your answer to part A, ensuring that you got that correct. Parts B and C, you must make an attempt on. If you get it right, nice job. Bonus points for getting both B and C correct. If you get it wrong, no penalty, but you tried it, and therefore I salute you for that. So remember, A, required. B and C, make an attempt. Try to get the right answer, but if you don't, no penalty. Now let me give you a little hint for part B. I gave you a hint for part A, a big hint for part A. For part B, notice what we had to do in that first aid problem? The second part required us to divide. We had to use that GCF, and we had to divide. That's what you're going to do for part B. And for part C, no hint there. You should be able to figure that one out. Also, you should be using the information from part B in part C, because typically when you have a math multi-step problem, yeah, you got to use the previous information. So there it is, folks. There's your problem. A is required, B and C are bonus. Give them a shot. If you have questions, feel free to email me. And I look forward to seeing your submissions, which can be done many different ways. You can write out your answers, show your calculations. You can type out your answers, show your calculations. You can explain yourself verbally. You can explain yourself in a video. You can make a screencast. You can make a podcast. You can make a Vine. I'm still waiting for someone to make a Vine. That would be awesome if you can explain this whole problem in 6 seconds or less. I would love that. That would be so cool. Basically, the world is your oyster, how you can submit your answer, your solutions, as long as I can see them. All right? Take care, folks. Have a great weekend.